In this lesson, students will identify parallel and perpendicular lines by their slopes and use that information to write line equations. So we'll talk about the slopes of parallel and perpendicular lines. And parallel lines have the same slope. So, for example, if you have two line equations, if I have a line y is equal to 1/3 x plus 2, and I have y is equal to 1/3 x, these two are different lines because they have different y-intercepts. One is at 2, one is at 0, but they have the same slope. So that means they are parallel because if they have the same slope, they will never intersect, and that's our definition of parallel. Perpendicular lines have slopes that are negative reciprocals. That means you flip the fraction and you change its sign. So, for example, let me go here. Example again, if I start with y is equal to 1/3 x plus 2, my slope is the coefficient in front of the x. It does not include the x, it's the coefficient 1/3. So a line that's perpendicular to that one would be y is equal to -3x minus 4. It doesn't matter what the y-intercept is if it's a different line. So here 3 is a reciprocal of 1/3. If 1/3 is positive, then the perpendicular slope would be negative. Negative reciprocals. You flip it and you change the sign. Okay, and then rotating, I have to pick that, and rotating a line 90 degrees yields a line perpendicular. So that's the same kind of thing when we think of transformations. So again, rotating a line 90 degrees yields a line perpendicular to the original. So if you rotated around the origin, you could essentially use those rotation rules to come up with your perpendicular line. So here are some examples for how this is used. Okay, write the equation of the line passing through 3, -2, and 6, 0. This is review from our very first unit. So we're just finding the line equation, which means we have to find the slope. If this is x1, this is y1, this is x2, this is y2, then you could say y2 minus y1 over x2 minus x1. I'm going to add the opposite, and I get 2 over 3. So that's my slope. My slope is 2/3. Now I pick one of these points. I'm just going to pick the first one here, 3, -2, and I substitute that into y equals mx plus b. So -2 is equal to 2/3 times 3 plus b. So -2 is equal to 2 plus b, and b ends up being -4. So all I'm doing is writing the line equation, which looks like this. Y is equal to 2/3 x minus 4. Okay, so in our second example, we want to write the equation of the line parallel to the example the line in example 1, but now we're going to pass through the point 12,7. So our first line equation was y is equal to 2/3 x minus 4. From this, I'm going to steal the slope. The slope is 2/3. I want a line parallel to that, so the parallel slope is also 2/3 because parallel lines have the same slope. And then I'm using this point, my x and y 12,7, to substitute in. So I have 7 is equal to 2/3 times 12 plus b. The 3 reduces with the 12, and so that ends up being 7 is equal to 8 plus b. If I subtract 8 from both sides, I get b is -1. So this line equation is y is equal to 2/3 x minus 1. Okay, so this time I want to write the equation of the line perpendicular to y equals 2/3 x minus 1, and this line is going to pass through the point -4, 1. So, again, I steal the slope. Okay, the slope of the original line is 2/3. So now I want the perpendicular slope. That means I have to flip it and change the sign. If I start with positive 2/3, then my new slope is going to be -3/2. And then I do the same thing that I've done before. I have an x and a y. I substitute in. 1 is equal to -3/2 times -4 plus b. The 2 reduces with the 4. That's a -2. And I have 1 is equal to 6 plus b. So b is -5. And you write your line equation, and it's y is equal to -3/2, because I want the perpendicular slope, x minus 5. So we're going to graph these three lines now to see what they look like. So let me just rewrite them here. The first one was y is equal to 2/3 x minus 4. The second one was y is equal to 2/3 x minus 1. And then the last one is y is equal to -3/2 x minus 5. So we'll graph these. The first one, -4, I start down 4, and I go up 2 to the right 3, put a point. Up 2 to the right 3, put a point. I don't know if I can use a straight edge on this thing to try to make this line straight. Let's see if I can. Oh, it kind of works. Okay. So that's my first line. Y is equal to 2/3 x minus 4. My second line starts at -1, and it still goes up 2 to the right 3. Up 2 to the right 3. So you can see these two. I can't use my straight edge because it just clicks to the next page. Try it this way. There we go. So you can see that those two lines, well, as best as I could draw them, this is y is equal to 2/3 x minus 1. Parallel lines have the same slope. So if I do the next one, -5 is my y-intercept. Now I go down 3 to the right 2. Or I can go up 3 to the left 2. And this guy, if I can put my straight edge on here without messing it up, goes up like that. So you can see this is y is equal to -3/2 x minus 5. You can see that they are perpendicular. This one is perpendicular to both lines. Well, these are parallel. So that's what a negative reciprocal slope does, okay? It makes the line perpendicular to the original. Have the same slope, and that's why finally, I can't do a lesson without a proof. So this is a very, this is called a coordinate geometry proof, okay? We're going to use slopes this time. I don't have to write a statement and reason. It says, given A, B, and C, these coordinate points, determine if the points define a right triangle, a non-right triangle, or no triangle. So what you have to do is you have to find all three slopes. Okay? You have to find all three because none of them can be parallel. If you have two slopes that are the same, then you won't have a triangle. It'll be like an open box. All right? If you have two slopes that are negative reciprocals, then you're going to have a right triangle. So all we have to do, we got to find the three slopes and take a look at them. I'm going to do the slope of AB, and that's equal to 3 minus a -2 over 6 minus a -4. That's 5 over 10, so that's a slope of 1/2. The slope of BC is going to be 9 minus 3 over 3 minus 6, so that's going to be 6 over -3, that's -2. And then you got to do all three slopes, the slope of AC, to make sure we don't have anything parallel. The slope of AC is going to be 9 minus a -2 over 3 minus a -4. So that's 11 over 7, and we are okay, I think. Because I have two slopes. These are negative reciprocals, and this is neither, so there's no parallel lines. Therefore, And here's what you have to write. You have to have a statement. You can like point these two out, and you can say slopes are perpendicular. And then you say the three dots mean therefore. Therefore, triangle ABC is a right triangle. Okay? You have to have a concluding statement when you do a proof like this. It's an easier proof to do. It's just calculations, but you've got to have this to get full credit. Okay? And that is a general rundown of slopes and parallel and perpendicular lines.